Hey guys, so let's discuss new round, which is round 4, AI engineering. Okay, so here the question is design an AI. Okay, yeah, the question is design an AI coding assistant similar to GitHub Copilot or Cursor. Okay, so you need to create system similar to Cursor, which will generate code for you, which will do code review for you, which will generate test cases for you, which will do testing for you, right? So all that functionality should be here or similar to a Cursor or a GitHub Copilot. So now, yeah, this is one of the highest probability AI system design round for Microsoft. Okay, especially for the team working on GitHub Copilot, Azure AI, Microsoft 365 AI, or Bing AI, Binge AI, or Azure OpenAI, and developer productivity. So now this round is not testing prompt engineering alone. Okay, it's not like you have to create a prompt engine. No, you will use prompt engineering. No, the interviewer want to know whether you can build a production grade AI system or not. Okay, so again, expectation differ by level. We will see answers based on three roles, which is the software engineer, senior software engineer, and principal engineer or the architect. Okay, so now here software engineer, which will have 2 to 5 years of experience. So under the expectation would be he should understand AI building blocks. Okay, what are the AI building blocks? LLM, RAG, vector, embeddings, DB, APIs. Okay, all these things. Now, senior software engineer, 6 to 12 years of experience, design a scalable AI system, optimize latency, cost, handle production challenges. Okay, all these things he has to discuss here. Now, principal engineer or architect, which will have 12 plus years of experience. Okay, so design enterprise AI platform with governance, security, observability, and multi-agent orchestration. So he should mention all these things in his answers. Okay, now let's see what software engineer, which will have 2 to 5 years of experience, will say for this. So his expected answer would be the AI coding assistant should help developers by generating code. Okay, what he should do, first he should generate the code, then explaining code. Okay, after that, fixing bugs, writing test cases, and answering repository questions, and assisting with the documentation, right? So documentation part, unit test cases, and then answering on the based of repository. Okay, repository will be the context here, and then generating code and fixing bugs, all thing he has to do it. Now to build this, I would use LLM with Retrieval-Augmented Generation, RAG. Okay, responses are grounded in the user's code base. Okay, so see, anyways you have to give request to LLM, right? But LLM has the huge data set. Okay, he will answer on basis of anything, like the context is very huge there, and sometimes it will hallucinate, sometimes it will give you irrelevant answer, right? So what we do, we send him context. Okay, that this is the context and answer based on this context only. Okay, don't go above the boundary of this context. Okay, so then in that case you can reduce the hallucination rate. So that is why we will be using here RAG. Now high level architecture, if you see, so see, this is your IDE. Okay, let's say I'm using my application in Cursor or VS Code. Okay, sorry, like VS Code, I'm using IDE. Uh, Visual Studio for my Cursor or GitHub Copilot. Okay, where I will download that extension plugin, and then so there user is typing something. Okay, user has given a prompt. So you will have a prompt orchestrator. Okay, which will handle all the prompts, and it will do all kind of things like input validation, and then output validation, and then all those things. So prompt orchestration, what it will do, it will take the prompt from user, and then it will go to the repositories you have, right? So that is the context for you. You want answer based on that context only and nothing about that. So it will retrieve the repository context. Okay, you will have a multiple repository, and then it will retrieve context from there. Okay, and the prompt which builder has given, it will add that prompt. Okay, with that context, and also apply guardrails. So what is guardrails? Input validation. It will help you with the SQL injection and all this kind of things. We will discuss all those things, and then it will send all this response to LLM API, okay, and then LLM API will stream the response, and we will show that on VS Code again, IDE again, okay. So component here will be IDE extension, that is the first thing, okay. You need to install the extension like we install for GitHub Copilot, okay. This plugin this extension we install. And then prompt builder, embedding model, okay. Embedding model, you know that in RAG everything we convert into embeddings, okay. Let's say I have a repository, okay, which has multiple modules, then classes, then Java files and everything. So it will convert all those things into embeddings, okay, text into numbers, vectors, and then we store that in a database. So that is the embedding. So embedding model, and then vector database, LLM, and then a streaming API. So these will be the components. Now senior software engineer will say here, I would design the assistant as a modular AI platform. Now he will divide that into the multiple services, okay, with separate service for retrieval, prompt orchestration, model routing, caching, evaluation, and observability, okay. So for each component he will just create a module. The primary goal are low latency, accurate responses, security, and cost efficiency. So this one will be the production architecture. So like developer will have the IDE plugin, let's say VS Code, okay, and then so he's using that in a VS Code, and then the request will go to API gateway first, which is the single point, single entry point, and then from there he will have this multiple modules, okay. So for example, authentication, he will have one module where he will be using OAuth and role-based access policies, okay, role-based access control, and then prompt service, which will build and manage prompt for the user. After that, RAG service, which will retrieve context from vectordb, okay. And then embedding services, so it will generate embeddings. Model routing, select the best model, okay. You can have different models, okay. So you can select best model according to your requirement. For example, if you just need to create a test cases, right, so you will use a simpler model. If you need to write the code, write the logic, you will use some medium level of model, okay, which will have the different cost. So you will do the cost optimization here as well. Then prompt cache, okay. So again, cost optimization, just cache the prompt, no need to again generate the embeddings and all. Then guardrails for the safety policy and PII filtering, personal information, okay. And it will just mask it with the star or something else. So then evaluation, so quality metrics and feedback loop will go on, okay. And observability, where you will track the logs or metrics or alerts and all those things. So then after that, this will be the modules, and then response will go to let's say Azure OpenAI or internal models like GPT-4o or Llama, Mistral, and then Phi, etc. And then it will stream the response in the form of tokens, token by token, okay. So design goal, so here VS Code is an IDE, okay, and or more preciously a lightweight code editor that becomes an IDE with extensions. A plugin is an add-on that extend IDE's capability. So here you are creating a plugin, okay. Now design goals, so yeah, the normal one, low latency, okay, high accuracy, enterprise security, cost optimization, horizontal scalability, and continuous evaluation. Now what principal software engineer, which will have 12 plus years of experience, he will answer in this case? Expected answer would be, I would build the coding assistant as an enterprise AI platform rather than a single application, okay. The platform should support multiple models, multi-agent workflows, governance, policy, enforcement, observability, and secure access to enterprise repositories. Enterprise architecture will be something like this. So IDE, user will use the IDE, okay, and then the request will go to API gateway. From there, again, different modules, what we just discussed, and then from there he will have multiple LLM provider. Now here he is talking about agnostic routing models, okay, for the LLM. Agnostic means multiple, so like GPT, Phi, Claude, and Llama, okay. So anything he can choose, and from there you will have different repositories as well, okay. GitHub, Azure DevOps, GitLab, Bitbucket. So it will support all these multiple things, okay, platform level. So multiple projects will use this kind of architecture. Now, guiding principle will be here, see, model agnostic. This is what I was talking about. So, model agnostic means your application is not tied to any one AI model or provider. You can switch between different LLMs with little or no code changes. Okay. And then enterprise security, cost aware routing. After that, governance, AI observability, and continuous evaluation. Now, let's discuss a few follow-up questions here. I think 5 follow-up questions we will be taking here. Okay. So, which LLM would you use? The very first question when you are creating this kind of applications, you will first, you will have a first question that which LLM you will be using. Okay. So, software engineer will say that for high quality code generation, see here you need what you need to do. You need to work with a code, right? So, for high quality code generation, I would start with GPT-4 4.1 class models or Claude class coding model. Okay. For lightweight on-device scenarios, smaller models such as Phi can reduce latency and cost. So see, when people say GPT 4.1 class model or Claude class coding models, they usually don't mean one specific model. Okay, they means the category of frontier AI model. Frontier AI model means advanced AI model capable of professional software engineering task. Now, these models are designed to understand large code base, okay, then generate production quality code, debug and refactor code, explain architecture, use tools and APIs as AI agents. Now, senior software engineer will say that selection depends on the model accuracy, model latency, okay, how much time it is taking, then cost, context window, code generation quality, and enterprise compliance, and use different model for different tasks. Now, principal or architect will say in this case, adopt model routing strategy. Now, instead of one model, he will be using multiple model and then he will use model routing strategy. Okay, so for example, if autocomplete is the task, then he will go with the smaller model. If explain code is the task, he will go with the medium model. Then refactoring large model because it requires complete code logic changes and all. Okay, not code logic changes, but yeah, he will scan the code and everything. Then architecture, so most capable model. This balance quality, latency, and cost. Fine. Follow-up question 2 is fine-tuning versus prompt engineering. Whether you will go with the prompt engineering or the fine-tuning. See, fine-tuning is, let's say you have a model and you have a few weight associated with model. Okay, if someone take out weight from the model, it means that they have taken model itself, because model is nothing but just weights. Okay, now how you assign how those weights gets created, you train the model. Okay, you fine tune that model, let's say on particular domain. Okay, then those weights will get created, and that is the real model thing, right? And then now using prompt engineering, you can use those weights, okay, and change the behavior of the response of the model. So that is comes to prompt engineering. But if you wanted to retrain the if you wanted to train the model, you will use the fine tuning. Okay, this is the main difference between fine tuning and prompt engineering. So software engineer will say that prompt engineering customize behavior through instructions and context without retraining the model, right? And fine tuning updates model weight using domain specific training data. So this is the main difference. Now, senior software engineer will say use prompt engineering when behavior changes frequently, okay, then knowledge changes often and fast iteration is required. Use fine tuning when consistent output format is required, specialized coding style is needed, and large labeled data sets are available. So now principal architect will say that I would start with prompt engineering and RAG because they are cheaper, faster to update, and easier to maintain. Okay, and fine tuning is justified only when prompt based approaches cannot consistent meet quality requirement. When you're not getting quality requirement with prompt based um, approaches, you will go with the fine tuning. Otherwise, you just use the prompt engineering. Now, follow-up 3 is explain RAG. What is RAG? Retrieval-Augmented Generation. Okay, so software engineer will say that Retrieval-Augmented Generation retrieves a relevant document from a knowledge base and add them with the prompt before sending it to LLM. This is what initially I explained you, right? This improves accuracy and ground responses in current repository content. Now, So for example, user has asked a question, so retrieval will retrieve relevant file, okay, which has the answer for that question, and then it will add that files with the prompt and will give it LLM. Using LLM will use its natural language processing, NLP and all, and will generate a response, and then we will give that response to user. So senior software engineer will say that RAG pipeline will be something like this. First, you embed repository files. Okay, you have given repository files to the like you have given the code base. Let's say, okay, it will convert that into embeddings and store these embeddings. After that, retrieve relevant chunk. When user will type something, it will just retrieve the relevant information from it, and it will rank the result. Let's say you are getting 100 files for that particular question, right? So it will re-rank them and will fetch top 10 files only, right? And then it will build a prompt and generate answer using the LLM. Okay, we'll send it to LLM prompt plus that context, and then we'll generate an answer from LLM. Principal architect will say that enterprise RAG should include the first one is hybrid search, means your vector and keyword. Keyword is your normal legacy, normal search, right? And then vector search is your semantic search. We have already talked about what is semantic search and all, right? In my design search system video where we were designing Elasticsearch. And then re-ranking and AI powered search also. Re-ranking, then access control, freshness management, citation support. Citation support means if he is referring from some external website, then that citation should he should be able to give, right? And then metadata filtering. Now, what is metadata filtering? Metadata filtering means that before retrieving document from the vector database, you filter the search using document attribute, okay, like metadata, so that LLM only see the relevant and authorized information, okay, and not anything else. So for example, without metadata filtering, if user is asking show me the leave policy, right? So the retriever searches all document. Some irrelevant or even unauthorized document may be retrieved, right? So that's why we will be doing the metadata filtering. The follow-up 4 is related to explain embeddings. What is embeddings? Okay, so software engineer will say that embeddings convert text to source code into numerical text or source code into numerical vectors. So semantically similar content is located close together in the vector space. You will have some vector space, okay, and you will have few vectors, means all the vectors here, and those vectors are like 0.25 and 0.26 is here, okay. Now you can have multi-dimensional, like this currently this is 1D. You can have multi-directional vector spaces, and all the similar kind of vectors will close together, and then you will do the approximate search on that, and it will retrieve just the neighbor vectors to you, okay. So that is how this thing is happening in AI. Okay, now see, LLM is what? It is just the predicting the next word. That's it. That is all we have. So for example, you have given one vector, it will predict its neighbor vectors to you. It will fetch its neighbor vector to you, but it is very powerful machine, so that it will predict the lots of things, okay. But that is the base concept of here LLM. Now, senior software engineer, so embeddings are generated for code, okay. For what all things you will generate embeddings? Code, documentation, APIs, comments, and design documents, okay. So similarity search retrieves the most relevant context. Principal architect will say that maintain separate embeddings strategies for source code, markdown means .md files, okay. Then API specification and architecture documents. Rebuild embeddings incrementally as repositories changes. Now follow-up question 5th, the last one is, I think this is the last one, chunking strategy. So what all chunking strategies you will use? Okay, so software engineer will say he will chunk the data based on function, class, and modules. Okay, so avoid fixed size chunking for source code. So the chunking will not be the fixed size, it will be based on function, class, and module. Senior software engineer will say that he will preserve semantic boundaries. Semantic boundaries means, let's say you have this sentence and then this sentence, okay, but let's say you have chunk this one and this one. So this is your chunk 1 and this is your chunk 2, but this sentence has no meaning until and unless he knows about the previous one, right? So he will he will preserve the boundaries and will take all this thing into one chunk, something like this. Okay, so include overlap between chunks to maintain the context. Okay, if you will include this, then only the context will get maintained, otherwise no. So that's why he will preserve the boundaries. Now principal architect will use language aware chunking. Okay, so hierarchy will be something like this. Let's say you have one repository. Okay, and in that repository you have multiple modules. Let's say order service. Okay, let's say order service, and then inside the service you have different files, and then you have the class, right? And then inside class you have a method, so it will chunk according to that. Okay, so now next follow-up question is, how would you reduce hallucination? Okay, so software engineer will say that use RAG, better prompt, low temperature, and return citation. Okay, and what is low temperature? Temperature is an LLM setting that controls how random or creative the model's response are. So let's say you have the low temperature and high temperature. Low temperature is between 0.0 to 0.3, let's say, and then high temperature is 0.7 to 1. So when you say 0 to 0.3 low temperature, it means that more deterministic, factual, and consistent output. And when you say 0.7 to 1.0 high temperature, so more creative, varied, and then unpredictable. So for example, if the user is asking question, what is capital of France? So, and if the temperature is 0.1, which is the low temperature, right? So the capital of France is Paris. Accurate answer. Okay, always give the same accurate answer. Now temperature is 0.9, high temperature, then in that case Paris is the capital of France. It often calls city of light and has inspired artists for centuries. So he will give this kind of answer. Okay, verbose answer. So the answer may become more verbose or imaginative, more factual task. Higher temperature can also increase the chance of incorrect and unsupported information. Now senior software engineer will say that he will add re-ranking, functional calling, and confidence scoring and validation. Okay, and what is functional calling? So it allows LLM to invoke predefined functions or API to perform real world actions to retrieve live data instead of generating everything from its own knowledge. So for example, book a meeting tomorrow at 3 p.m. So the LLM call the calendar API to actually schedule the interview. So external calling. Okay, function calling. Now, how would you reduce hallucination? Principal architect will talk in depth about RAG, then tool execution, policy engine, output validation, and then human approval for sensitive action. Like he will click on apply button, then only the further process will happen. Now, follow-up question 8 is related to multi-agent architecture. Okay, so software engineer will say that he will be using here multiple agents, like one for code generator, another for test generator, then document agent. Okay, now senior software engineer will say that he will coordinate agent to delegate the works. For example, first user will ask a question, so it will go to planner. Okay, now planner understand the request to break it down and assign the relevant agents. So let's say one agent is doing code agent, one is code agent, then after code test agent will work, then review agent will work, and then security agent will work. Okay, and then you will get the final response. So you will have the multiple agents there which will do their task, and planner will assign these tasks to the correct agents. Now principal architect will say that introduce specialized agents. Okay, like planner, retriever, coding, testing, security, architecture, document, compliance. So different agents for different tasks. Shared memory coordinate collaboration. He will use the word shared memory coordinate collaboration. What does that mean? All AI agents share the same information and update, so they can work together effectively. Okay, so follow-up question 9 is related to guardrails. And guardrails, so software engineer will say that he will do the input validation, output filtering, and prompt protection. Okay, in this guardrails. Senior software engineer will say that he will prevent prompt injection, secret leakage, and unsafe code generation. And principal architect will say about enterprise guardrails like RBAC, okay, role-based access control, policy engine, like which will enforces business security compliance rules before and after an AI request is processed, and then DLP, data loss prevention. Now it is what is DLP? So DLP is a security mechanism that prevents sensitive or confidential data from being exposed, leaked, and shared with an unauthorized user or external systems. Now PI I'm asking audit logs and compliance enforcement. So that's it. Thank you.